Hi. We'll go like this. We can go like this. We're good. We're good. So GlobalReach, a little bit of background on GlobalReach. We are a federated AAA provider. We provide services like Eduroam, Passpoint, those kind of things. We were asked to participate in the World Wi-Fi Day to bring together the connected cities. And I'm going to share some of the findings that we saw around them. Some good, some not so good. Places we can improve on, but it needs the industry to help us do those. So the city roaming projects, we had some big cities that were involved in the World Wi-Fi Day: Singapore, New York City, San Francisco, San Jose. And we're talking about Hotspot 2 here. We're talking about connected experiences where I can sign up in one city and I can roam. My credentials will be able to be roamed and authenticated in other cities as part of that. We do want more to be involved in next year's World Wi-Fi Day. We were connected. To bring all of this together, we had to connect a lot of roaming hubs. So our friends at Acurus, BSG, and Cineverse. There were over 20 operators worldwide involved in this particular project. So as you can imagine, that took some bringing together, lots of late night planning calls and things like that around. So these are the 5 points that I'm going to try and explain and talk about. Again, all of things that really we should know. I'm just bringing them back to everybody's attention. There was a lot of network configuration required to make this happen, not just at local level. Obviously, the cities building and deploying their own networks have their own infrastructure, their own networks. But we needed to connect these networks together through a variety of different roaming hubs. And this is radius data, so this needs to be secure. So we had a lot of IPsec tunnels between various hubs and various partners to make this achievable. We needed to connect these cities via the most economical route. This is also going to come on to another point that I'm doing, but the most effective route. When we are authenticating somebody, we don't want it to take ages and ages and ages. We've all sat at a phone and we see the little spinning wheel and we just wait in there. That's not a great experience. So not only do we want it secure and seamless, we also want it very, very fast. Lots of local hub and connections and realm setups that needed to happen in radius servers via our partners, via the cities, and those kind of things. They all required a lot of planning. There's lots of late night calls between various engineers making all of this happen. So these are the things you need to think about when you're planning for these kind of things. The last two are what I'm really going to talk about. Focus on latency. Latency ruins the experience. If it's going to take 3 or 4 seconds to authenticate somebody because we're taking a radius packet from this location through to North California, then sending it across to Europe, then sending it to Ireland, then sending it back to the US to that subscriber store, that ruins the experience. So again, these interconnections, there are things we can do to improve on that. And the multiple different devices that we had to provision. Across these different cities, people have lots and lots, and I mean lots of different devices from all sorts of different manufacturers. So the first challenge was the interconnected radius servers that needed to be connected. There was a lot of configuration in there because we needed to make sure we ship those radius authentication requests the most effective route that we could to do that. It meant a lot of setup and a lot of configuration. They are actually true representative dots on there of the various roaming hubs and various networks that were involved. We was asked, we have an OSU, an online sign-up server for Hotspot 2 and Passpoint, because there are lots of devices out there that don't have SIMs that the carriers can't provision. They can't just enable eSIM on an iPad if it hasn't got a SIM card. So we needed another way of doing that. And the way of doing that is through something called an OSU, an online sign-up server. It's actually part of the Release 2 specification. It's not part of the release 1 specification, but we've had a need for the last 2 or 3 years to provision devices. So GlobalReach went ahead and we worked with various manufacturers to work and understand how we can provision those devices as frictionless as possible. And I think that's a really key word, frictionless. We need to make sure that we onboard those devices as simple as possible. So again, I'm going to talk about latency. Latency, it ruins the experience if it's going to take 3 or 4 seconds to authenticate somebody. And again, those interconnected patterns that you see, having radius data going from North America across to Europe, and then down to Singapore, and then over to Sydney, those kind of inter-network exchanges take time, take latency. There are smarter ways to do that, and one of the ones we're going to discuss on the next slide is a solution that we've put together. Proud to say it's been shortlisted for an award this evening, a little plug there. But it's something called an edge radius. And an edge radius has the intelligence sent to it. So this allows a roaming hub, whilst it's got one billing mechanism that needs to correlate all that information, allows to put information at the edge of the network. And I know that sounds a little bit backwards because everybody's bringing data together and into centralization and things like that. But when we're talking about latency and authentication, we need to be able to do that really snappy. When you connect to an access point, you want to be authenticated really quick. So we've developed a technology that we call edge radius. Contained within there is something called, if we start going too technical, it's a secure distributed memory cache. This allows things like from trusted networks to terminate the EAP tunnel onto the in-country radius, which means you can now see the inner authentication. Through a trusted network, that can go off to the carrier for them to authenticate that and send back. So the first time, just like stepping off a plane, it takes a few seconds longer for us to join the cellular network. The first time, this still takes a few seconds for us to do that because our credentials are potentially, let's say, in Sydney. Once we get that authentication request back, we allow the carrier to send 2 specially formed radius attributes. One is called the time to forget, TTF as we call it. That is an explicit time that is sent with that request to the secure memory cache. And this is truly in memory, nothing is written to disk. So again, we have taken lots of security steps around this. But this allows them to say, we're going to trust that user. Chris's account, his Wi-Fi account, his roaming account, is valid till the 27th of November. So I don't want to stand in his way and slow him down from authenticating till the 27th of November. So what happens then is we see that authentication request. The DSMC looks that up and goes, I can send an access accept back. It then sends accounting data to the central hub, because that's all the hub is often interested in, is so that they can bill successfully. So we've speeded up the latency around that. We also have something that we appended to it called a time to renew. And this is a function that allows our platform. So whilst I'm trusted till the 27th of November, in 3 days' time, I might cancel my account with that carrier. So what they can do is they can send, as part of that TTR, is the ability to say, once every 24 hours, I want you to do a MAC authentication on behalf of that client. It can send a MAC address authentication through to the carrier. The carrier can either accept that or deny that. If they deny that, we scrub them out of the memory cache immediately. If they authenticate that, we immediately send a stop packet because we don't want to have lots of mislaid authentications on a client's account. We don't want any data packets or anything like that to show if it's going against. So it's a simple transaction that we do on behalf of the client. That's kept our memory cache up to date. So again, that roaming experience is really good. There are multiple ways to provision a device. This is the last point that I want to go on to. We are still seeing that today. Most of the devices, in fact, all of the devices that are still in public hands are all release 1. So we don't have a single standardized method to provision that handset for Hotspot 2. So we've had to invest a lot of time, a lot of development skills and resources into provisioning Android, Android 5, Android 6, Android 7. We've had to do the same with Apple. all of those various flavors and things like that around that we need to do. They're all different provisioning methods. Windows 10 brought out a release 1 capable way of provisioning last year. And we're pleased to say and announce today, it's also on our website, that we are supporting release 2, and Microsoft are supporting release 2 for Windows 10 going forward. And I believe that will be available sometime in December. That's really all I've got to say that we've learned from the cities.